show you, and we're going to go through all the different types of processes that you can use the stoichiometry information with. And we have the equation, 2 sodiums plus 1 chlorine is going to give us 2 sodium chlorides. Now, here's the question. If we have 10 grams of sodium, how many grams of chlorine do we need to use up all 10 grams of sodium? So I don't want any extra sodium in our reaction. I don't want any of that. Now, there's a process to this. There's a checklist to this. So it's a step-by-step process, and you need to know how to do this. Now, the first step is, well, think of the mole conversions that we've done. Every type of mole calculation and conversion, what did we usually do? Well, we did unit analysis, but what were we trying to find? If I had 10 grams, what was the first thing we converted it to? To moles. And that's going to be the same thing that we do here. Everything we got to go through moles. Moles is the grand central station of stoichiometry. You got to get to moles, because then what we found here isn't like we can't say this is like 2 grams to 1 gram. That's not how it works. It's 2 moles to 1 mole. And since the balanced equation is comparing moles of elements and compounds, we have to convert things to moles because we do most of our work in moles. So first thing is convert the 10 grams of sodium to moles of sodium. Now, we need to do that unit analysis stuff. So I get 10 grams of sodium. Now, what goes in the bottom and what goes in the top here for the second part? All right, just doing the unit analysis part of it. If I have grams up here, I need to divide out the grams. I need to get rid of them, and I need to figure out what the moles of sodium are. Now this, right here, 1 mole, how do I figure out 1 mole of sodium? You look at the molar mass. So we're going to have to look at the periodic table. So this is going to be a molar mass conversion. And so our molar mass conversion, sodium is 22.99 grams, so 22.99 grams. And this is the first calculation that we have to do. So with the 10, there's no good place for this. 10 grams in the 22.99, what am I going to do with those two numbers? Multiply or divide? Divide. So 22.99. And so I get this big number, 0.434971727. So this is equal to 0.434971727. So if we were given an answer, like I said, right now we're not huge on the sig fig stuff. We'll worry about that at different points when we're doing measurements and things like that. But for this, I always say just go 2 decimal places. That'd be okay. So if you're giving this answer, it would end up being 0.43. moles of sodium, but this is what you use in calculation. So why would we not want to use the rounded version as opposed to the actual version?
It's not very accurate.
100% correct. This is more accurate than the rounded version. As soon as you round a number, you introduce error into the equation, and then if you keep using something that's wrong, it's going to get more and more wrong. It's going to compound on itself. The errors will compound, and then you're going to be way off. Well, maybe not way off, but you'll be off as far as the amount of reactant that you need. And if you are dealing with chemicals and your reactants are way off, you could lead to some issues in the lab, some safety issues that you don't want to have to deal with. So I'm going to keep that number in there, and we could store it. I'm not going to store it because I'm just going to keep the number. But that's step one. Convert to moles of sodium. Now, 2. We're going to use the mole ratios from the equation to convert to moles of Cl2. So I'm going to take this amount of moles, and I'm going to convert it to moles of Cl2 using the mole ratio. So that's step 2. Now the nice thing about this is you're going to do the same process every single time. So once you know the process, everything's good to go. Which is why I stress that you have to know the process of unit analysis, because that's what you're going to use all the time. So instead of trying to memorize what you got to do with this, and whether you got to multiply or divide all the time, and you understand the whole unit analysis side of stuff, that's something you don't have to remember anymore because you got the process down. Now we've got a new process. And the thing is, the math in chemistry is just a process over a process over a process over a process. So if you understand the processes, you're good to go. And that's a lot less to remember than trying to remember each individual case. The process alone will take care of that. Now, we are going to use this amount. I'll just write it as 0.43 with a couple dots at the end of it. Moles of sodium. Now, what's the molar ratio between sodium and chlorine? Because I'm going to have to put moles of sodium here and moles of chlorine up here. So how many moles of sodium to how many moles of chlorine? 2 to 1. So we put our mole ratio in here. So here's our mole ratio. And so now it'd be that value. I multiply by 1, but multiply by 1 doesn't do anything, and then I divide by 2. So I'm going to divide by 2. So I took my answer, divided by 2, and I got 0.21. Oh, that's a little bit better. 0.21748 5863. And that's moles of chlorine, Cl2. So that's the moles of Cl2 that I'm going to have to use. Now 3 Now what we're going to do is we're going to convert the moles of chlorine to mass. Now, for Cl2, we have to figure out what the molar mass of Cl2 is. So the molar mass of chlorine. What's the molar mass of chlorine? 35.45 grams. But do I have chlorine? But how many chlorines do I have? 2. So you can multiply that by 2. I figure it's just easy enough to add. 45 and 45 is 90. And then 35 and 35 is 70. So 70.90. So 1 mole has 70.90 grams of Cl2. So now, and that's what happens when you have your diatomic elements. You have to make sure that you have 2 of them because it's diatomic. Because in a reaction, there are always going to be 2 that are going to form that diatomic molecule. So now we're going to convert this. So I have to use the moles that we calculated up here. That tells me how many moles we got there. So it's 0.21 and change. I'm going to use that answer. And since I have moles, I know 1 mole of Cl2 because that's what we're going to do. And this is molar mass again. How many grams are in 1 mole of Cl2? 70.90 grams of Cl2. So now the next question becomes, well, that didn't help. What do I do with this value? I have 0.21 and change. What do I do to that? Yeah, we're going to multiply. So I'm going to take this answer, multiply it by 70.90, and I'm going to get 15.4197. And round that to about 15.42 grams of Cl2. Now, anybody know what those 3 dots mean?
Therefore.
Yes. 3 dots mean therefore. Or there's a predator in the room and he's about to shoot his laser. Therefore, we need... Whenever you put therefore, that's like the final answer. That's your answering the question. A lot of times I see the work that you guys give me where you don't give me an answer. You just do the work and then expect me to figure out what the answer is. You actually have to go to completion. You have to finish the answer, write the answer out. So therefore, we need 15.42 grams of Cl2 to have the 10 grams of sodium fully react. And now, that's what stoichiometry does for you. You go through this 3-step process where you start with an amount of reactant, you convert it to moles, then you use your mole ratio to figure out how many moles of the other substance you need. And then you use molar mass again. And you're able to figure out how much of this substance of chlorine that we need in order to make this reaction work. Now, if we go into the lab, we know exactly how much sodium we need, exactly how much chlorine we need, put them together, and what we're going to get is sodium chloride, and what's going to happen is that 10 grams of sodium is going to be used up totally. And that's one of the things we want to know is we don't want to have extra stuff. We don't want to have a bunch of reactants left over afterwards, because then we're just wasting. Because a lot of times once we're done, we're just going to get rid of it. And especially if you're in a manufacturing process, you don't want to have excess reactants afterwards, because a lot of times afterwards they'll just get rid of stuff. So you want to minimize that amount of waste, which minimizes costs. And so in a big picture business sense, you need to know this stuff in order to make the reactions actually work. But also, if I just put 10 grams of sodium in with 10 grams of chlorine, it's not going to react as much. You're not going to get as much product out of that as you will. Because I need at least this amount of Cl2 in order to make that 10 grams fully react. If we came back with, if I said, all right, I have 15.42 grams of chlorine, and did the whole process, we would have ended up with figuring out that we need 10 grams of sodium in order to make the reaction work fully and completely. And that's what this stoichiometry is going to do for us. That's what this whole process and the math behind it is going to do. And what we want to do is we want to make sure that we can do the math and understand exactly what the reactions are going to be before we actually do the reactions.